In previous videos, we have discussed active method of mixtures. That means we have completed 7 activities. So next what we are going to discuss means we are going to discuss about determination of specific heat of solids. So let's see what is specific heat of a solid. So today our concept is about to determine the specific heat of solid. Yes, we are going to determine the specific heat of a solid. What type of solid means? It is lead shots. Yes, we are going to know about specific heat of a lead shots. So lead shots are nothing but they are small metal balls which are used in the missile guns. We will use some metal balls to shoot. Yes, so they are lead shots. So today what we are going to discuss, we are going to discuss about determination of specific heat of a solid. Yes. So what is our aim means to determine the specific heat of a solid. So to achieve that aim, what materials are required means we require a copper calorimeter. It is a copper calorimeter which is having lid on it. Yes, it is a copper calorimeter which is having lid on it, and that lid is consisting of two holes. In first hole, we have to insert a thermometer. And in second hole, we are going to insert a stirrer. So afterwards, what we have to take means we have to take wooden box. Next, we have to take a induction stove. On that induction stove, we have to keep a beaker. In that beaker, we have to take some water. And some of lead shots are present. Yes. Okay. So what is this? It is the thermometer. It is stirrer. It is calorimeter. It is wooden box. It is some stove. This is water. These are lead shots. In this, okay, I will say. Yes, so what materials are required? First, you have to take a calorimeter. In that calorimeter, what you have to keep? That calorimeter is going to have one lid. That lid is consisting of two holes. In first hole, you have to place a thermometer. In second hole, you have to place a stirrer. Next, all that equipment should be kept in wooden box. Next, what you have to take? We have to take a stove. And on the stove, you have to place a beaker. In that beaker, you have to pour some water. And again, you have to take some lead shots. These all are required to do this activity. Okay. So first what you have to do with these apparatus means, first you have to measure the mass of empty calorimeter. First, you have to measure this mass of empty calorimeter. So, mass of empty calorimeter. So, when you measure the mass of empty calorimeter, what weight it is going to get means it is M1. So, the mass of empty calorimeter is M1. Next, mass of, next what we have to take means you have to pour some water in this calorimeter. What you have to take? You have to take some water and pour water into this calorimeter. So, first you measure the mass of calorimeter, that is M1. Next, pour some water in calorimeter. Then you have to measure the mass of water and calorimeter. So when you measure the mass of water which is present in calorimeter, so what weight you are going to get means the mass of calorimeter and water is M2. Yes. When you measure the empty calorimeter, what is its mass? Its mass is M1. So when you are going to measure calorimeter along with the water, its mass is M2. So when you pour the water into this calorimeter, its temperature is at room temperature only. It is normal water. It is not hot water. Water which you poured in calorimeter, for the first time it is having a room temperature. Next. Now, we want to know the mass of water. So, mass of water. So, when you measure a calorimeter, an empty calorimeter, you know that its mass is M1. And secondly, what you did that you measured calorimeter and water mass. So what it came that calorimeter plus water is having mass of M2. That means when you gain the mass of calorimeter and water, if you subtract the mass of calorimeter, you are going to attain mass of water. Yes. So already you have measured the mass of calorimeter and water. And you also measured mass of calorimeter. So when you got mass of calorimeter and water, if you subtract the mass of calorimeter, then what you will get? You will get the mass of water. That means if you subtract from M2, yes, M2 is consisting of calorimeter and water. So from this, what you have to subtract? The mass of calorimeter. What is the value of mass of calorimeter? Mass of calorimeter is M1. So what you have to write? M2 minus M1. Yes? Okay. Now we know the mass of empty calorimeter, mass of calorimeter and mass of water. So let's see about temperature. Yes. So temperature of calorimeter and water. Calorimeter and water. So first we took a empty calorimeter. In that calorimeter you poured some water which is present at room temperature. So when you take that water in a calorimeter at room temperature, it is going to have a temperature of T1. Yes. At initial state, the water is at room temperature and calorimeter is also at room temperature. They both are having equal temperature. So that temperature we consider it as a T1. Next. Okay, up to here what we did? Just we took a calorimeter, in that we just poured a water, that's it. So next what we are going to do means, so take a stove, on that you just place a beaker and pour some water. In that water, first you have to heat this water up to 100 degrees Celsius. Yes, what you have to do? You have to heat this water up to 100 degrees Celsius. So when you are going to heat this water up to 100 degrees Celsius, so then you have to take these lead shots into that water. Yes, so when this water gain 100 degrees of temperature, when steaming is happening here, then you have to place these lead shots into this water. Yes, so when you place that lead shots into this water, what happens? That lead shots also going to gain that 100 degrees Celsius temperature. Yes, yes. So when it is going to gain its 100 degrees of temperature, then immediately without any lid, just take that lead shots and put them into this calorimeter. After lead shots are going to gain that 100 degrees Celsius, what you have to do? You have to take that lead shots from that beaker and you have to put that lead shots into this calorimeter. So now we are going to place that lead shots into this calorimeter. So when you keep that lead shots into this calorimeter, what happens? Here the water is having any temperature? No, it is at room temperature. But here lead shots are having temperature. Yes, so when these hot lead shots are placed in this water, what happens? The heat energy which is present in lead shots will be transferred to the water. Already we know that heat flows from a body at higher temperature to a body at lower temperature. So here which body is having higher temperature? Lead shots is having higher temperature. So what happens? The temperature, the heat which is present in lead shots is going to be transferred to the water. The water is at lower temperature. So when it is going to transfer its heat energy to the water, what happens? It will come to a state of thermal equilibrium. That means they both will attain same temperature at a point. So that state can be called as thermal equilibrium. Okay. Next. So here we have measured the temperature of calorimeter and water. Okay. Next we are going to measure the temperature of lead shots. Here when you heat that lead shots, it is going to obtain the temperature of T2. Yes, so the temperature of heat lead shots will be T2. Next, so already we have calculated the temperature of calorimeter and water. But after placing these lead shots into here, we have to calculate the temperature of lead shots plus calorimeter plus water. So when you place these lead shots into the calorimeter, we have to measure the temperature of this calorimeter, lead shots and water. Yes, so how much? It is T3. Is T3. Okay. Now, what is the specific heat of water? The specific heat of water will be denoted by specific heat of water will be denoted by SW. Specific heat of water will be denoted by SW. And specific heat of lead shots will be denoted by SL. SL. And specific heat of calorimeter is denoted by SC. So what is our aim? To find out the specific heat of lead shots. Yes. So specific heat of water is denoted by ice W, and specific heat of lead shots is denoted by SL, and specific heat of calorimeter is denoted by SC. So now we know about the mass, the temperature, and with which symbol we are going to denote that. Next, what we have to know, we have to know what is the temperature difference taking place here. Yes, so we know that when you take a body is having higher temperature, when you are going to mix into that a body is having lower temperature, they are going to have the net heat loss is equals to net heat gain. Who is losing here? The net heat loss is by lead shots. Yes, so the net heat loss is being done by lead shots and net heat gain is done by water. That means lead shots are going to lose its temperature and water which is present in calorimeter, it is going to gain its temperature. So what happened here? The net heat loss is equals to net heat gain. It is the principle of method of mixture. So if you observe what happened here, the net heat loss is equals to net heat gain. So according to this, what we can say? We can say the specific heat formula. So what is the formula of specific heat? Q equal to ms delta T. So here heat, mass, specific heat and change in temperature. So before going that, let's see about difference in temperature. So here, so let's see the temperature difference in lead shots. Yes, so if you observe when lead shots are placed here, it is going to have 100 degrees Celsius, which is having higher temperature, that is named as T2, and after mixing here the lead shots will lose its heat energy. So it is going to have how much temperature? When it loses its heat energy, it is going to have T3. So what we can write the temperature difference here? The temperature difference of lead shots is T2 minus T3. That means what we are doing here, the lead shots which is having higher temperature minus the lead shots which is having lower temperature. Next we have to see the temperature difference in calorimeter. Yes, so calorimeter at initial state it is going to have T1. Next after mixing this one it is going to have T3. So what temperature it is going to have? High one. The high one is T3 minus T1. Yes, the calorimeter at first it is going to have T1 and after mixing this lead shots it is going to have temperature of T3. So first we have to write the higher one, next you have to write the lower one. So here the higher one is calorimeter is having T3, it is the higher value. So we have to write higher temperature T3 minus and lower temperature of calorimeter T1. Next, temperature difference of water. Yes, so here at initial state the water is at room temperature. When it is going to have T1. Yes, at initial state the water and calorimeter is at temperature of T1. Yes, next after keeping this lead shots into that calorimeter, what temperature it is going to have? It is going to have temperature of T3. Yes, so here what temperature we have to write? The higher temperature minus lower temperature. So here the higher temperature is T3 and lower temperature is T1. Yes, so the temperature difference of lead shots is T2 minus T3 and temperature difference of calorimeter is T3 minus T1 and temperature difference of water is T3 minus T1. So okay, now we have to substitute these values into this formula. So what we are going to find? We are going to find the specific heat of solids. Yes, we are going to find the specific heat of solid. Which solid? It is lead shots. So first what you have to write here? The net heat loss. Here which one lost? The net heat loss is by lead shots. This equals to the net heat gain. Who gained? Here the calorimeter and water gained. So here the net heat loss means who lost? Here lead shots. So QL is equal to net heat gain. So who gained here? calorimeter plus water gain. So calorimeter plus water gain. So what we have to substitute now? We have to substitute all these values into that formula. So the net heat loss means we have to write lead shots. So lead shots value we are going to place now. So already I wrote what is Q. Yes. So this Q value which is having mass, specific heat and difference in temperature. So here what we are going to substitute? Mass, specific heat, temperature difference in lead shots. So let's see about it. So mass, what is the mass in lead shots? The mass of lead shots we forgot to calculate. Yes. So let's measure it. So the mass of lead shots. So the mass of lead shots when we will get means when you know the mass of this lead shots, water and calorimeter. The mass of lead shots, water and calorimeter is M3. It is M3. So when you are going to get this M3, if you subtract the values of the mass of temperature and temperature of calorimeter and water, when you are going to subtract calorimeter and water, what you will get? Lead shots. So here if you want to get mass of lead shots, what you have to do? You have to subtract the values of calorimeter and water. So whole mass of it is M3, and if you want to get only mass of lead shots means you have to subtract the mass of calorimeter and water. So the whole value is M3 minus mass of calorimeter and water is M2. Yes, so mass of lead shot means the whole value is M3. That means calorimeter, water and lead shots. So that value is M3. From that what you have to minus? You have to subtract the calorimeter and water mass. When you subtract the calorimeter and water mass, you are going to get the mass of lead shots. That is M3 minus M2. Yes. So what is the mass of lead shots? It is M value. M value means here what you have to write? You have to write M3 minus M2 into specific heat of lead shots. It is denoted by SL. Next, difference in temperature of lead shots. What is the difference in temperature in lead shots? It is T2 minus T3. Next, QC means about calorimeter. So calorimeter mass. What is the mass of calorimeter? It is M1. So M1 into specific heat of calorimeter is denoted by SC. Next, difference in temperature of calorimeter is T3 minus T1 plus how much? We have to write about water's heat. So water's heat means first you have to write mass. So what is the mass of water? Mass of water is M2 minus M1. So let's write here M2 minus M1. Next, we have to write specific heat of water. Specific heat of water is denoted by SW. Next, difference in temperature of water. So water is having how much difference? It is T3 minus T1. Yes, so now you got the values of heat of lead shots and heat of calorimeter and heat of water. So what you are going to obtain? We are going to obtain the specific heat of lead shots. So let's write the formula of specific heat of lead shots. So SL is equal to M1 into SC into T3 minus T1 into plus M2 minus M1 into SW, specific heat of water, into T3 minus T1 by these values will goes to the denominator side. Already you know when values are going to another side, they will go to the denominator side. So here what will happen? M3 minus M2 into T2 minus T3. Yes. So what is the specific heat of this lead shots? The specific heat of lead shots, we have derived it. It is M1 SC into T3 minus T1 plus M2 minus M1 into SW into T3 minus T1 by M3 minus M2 into T2 minus T3. Yes. So this is the determination of specific heat of a solid. The solid is lead shots. We have determined the specific heat of a solid. So what happened here? Here when you have taken this copper calorimeter and you kept a thermometer. So when you kept this thermometer, it is initially at room temperature. At that time no raising in thermometer, but when you mix the lead shots into that, automatically thermometer reading will be raised, and after a certain time it is going to gain at same temperature the lead shots and water. When they are going to gain that, net heat loss is equals to net heat gain. We are going to find the specific heat of a solid, that is lead shots.